Welcome to datascience.show, the podcast where data science meets executive leadership. We talk with top AI and analytics thought leaders about turning data into real business impact. If you're a C-level leader or data expert shaping the future, you're in the right place.
I'm your host, Mirko Peters. We explore how data science and AI drive real business impact, straight from the leaders making it happen. Today, a compact, fundable playbook to stress test machine learning systems and convert fragility into measurable resilience. Model failures aren't a technical curiosity, they're a business risk. In the next 23 minutes, I'll give you explicit artifacts you can take to the board, 2 sample SLOs, a rollback checklist, a 1-paragraph runbook, and a 90-day pilot plan. This is decision-first guidance, built for executives who need to budget, govern, and measure AI reliability.
Quick framing before we dive in. When I say playbook, I'm synthesizing lessons from multiple CDOs and ML leaders. Where I provide a template, consider it prescriptive. Where I recount examples, I'll flag them as aggregated. This keeps us practical and governance ready.
Let's sketch our composite guest, a chief data officer at a Fortune 500 retailer with global data flows, real-time pricing models, and regulatory constraints. Responsibility covers model development, feature pipelines, deployment, and most importantly, business-facing decision outcomes. Typical failures: silent data drift, vendor feature changes, latency spikes during peak traffic, and surprise edge cases that push poor decisions into the product. These failures cost revenue, customer trust, and sometimes regulatory exposure. That composite matches what I've seen across organizations. Often the failure starts as a small data schema mismatch or a vendor feed change, and by the time product notices, the model has been making bad decisions for days. The governance gap isn't intent, it's visibility and a lack of clear rollback criteria. We learn to treat those assumptions as testable risks.
Good. That sets the stage. Now, the core. Move from strategy to execution. First, define tangible failure modes and map them to business impact. I group them into 3. Data layer failures, schema drift, missing records, model layer failures, concept drift, performance degradation, and infra layer failures, latency, resource exhaustion. For each, translate impact into dollars or key customer metrics: churn, conversion loss, regulatory fines. Executives need numbers, not abstractions.
Exactly. One example, a pricing model that drifts during a holiday sale produced a 2% revenue leak over 48 hours. That's a board-level figure. When you present an SLO tied to expected revenue protection, the conversation changes from academic to fundable. Which brings us to 2 board-ready sample SLOs you can adopt immediately. First, decision-level error cost SLO. Wording: maintain expected decision error cost below $X per week for top-line revenue impacting models, measured by post-decision reconciliation within 24 hours. Operationalization notes: pick top 5 models, define ground truth reconciliation windows, and set $X as a fraction of weekly revenue. Start conservative. Second, model MTTx SLO, mean time to explainable recovery. Wording: restore acceptable decision quality or roll back to a validated fallback within 4 business hours of a detected degradation event. Instrumentation: automated alerts, a runbook trigger, and a rollback pathway. Those SLOs are effective because they target business outcomes and recovery time, not just accuracy numbers. We used a similar MTTx target and reduced customer-facing incidents by half in the first quarter after implementing it. The key is measurable detection and an agreed rollback path. Speaking of rollback, here's a template rollback criteria checklist you can attach to any model. 1. Detectable deviation in the primary decision metric beyond threshold for 2 consecutive windows. 2. Failed post-decision reconciliation indicating systemic bias or revenue loss. 3. Manual product complaint surge tied to model outputs. 4. Failure to meet latency or throughput SLAs affecting user experience. 5. Legal/compliance flag from automated checks. Each item should map to an automatic or manual rollback action with named approvers and a communication plan.
I'd add one operational note. Every rollback path should be exercised during a simulation. Teams often approve rollback steps on paper and then freeze when the real event occurs because they never practiced it. A dry run uncovers missing permissions, unclear ownership, and timing issues.
Let me give you a one-paragraph runbook snippet you can paste into your operational docs. On detection of a model degradation alert, the ML responder performs quick triage, verifies signal integrity, run lightweight shadow replay for the last 60 minutes, compare recent decisions to fallback baseline, and decide rollback if error cost exceeds the predefined SLO or if reconciliation fails. If rollback is executed, notify product and legal, open an incident ticket, and start root cause diagnostics with a 72-hour remediation target. Use that as your minimum viable runbook. It's short, action-oriented, and auditable.
It's concise and governance-friendly. Another important piece, low-blast chaos experiments. Start small, keep blast radius tight, and get legal/product sign-off. Examples to run in a controlled window. 1. Data feed interruption simulation, where a subset of downstream services receives delayed rows. 2. Feature lag injection, where the most volatile feature is frozen for 30 minutes. 3. Latency spike tests, simulating a 2x response time increase for inference for a 15-minute window. Each test must include monitoring for decision-level metrics, automated rollback triggers, and a post-mortem template focused on risk reduction.
Translate findings into fixes and metrics. If a feature lag test shows increased error cost, your remediation might be a fallback model, input sanity checks, or feature caching. Metricize it. Baseline expected weekly error cost, post-test observed error cost, and projected annualized risk reduction if fix is implemented. That's how you convert experiments into a dollar ROI for the board.
Teams often underestimate the instrumentation work. Observability pays for itself. Fine-grained telemetry for input distributions, decision-level reconciliation, and latency histograms let you target fixes that actually move the needle. We built an observability checklist and tracked the percentage of incidents detectable within 5 minutes. It became a KPI tied to engineering bonuses.
Now, funding and accountability. Treat resilience as an auditable initiative. Option A, CapEx for platform-level observability and API redundancy. Option B, OpEx for managed chaos testing services and vendor rollback credits. Build an accountability matrix. Model owner, platform owner, product owner, legal, compliance, and incident commander. Attach resilience tasks to quarterly roadmaps with explicit story-level estimates and a stop-go decision gate after the 90-day pilot. Board communications matter. Create one slide that ties your pilot to reduce dollar risk. Start with baseline expected weekly loss from model incidents, show pilot interventions, SLOs, runbook, observability, and project residual risk with and without investment. Include a single KPI for the board, for example, expected annual revenue protected, or median MTTx. That keeps the conversation focused and auditable.
Here's a practical 90-day pilot plan you can propose to finance. Week 0 to 2, scope and approvals, legal sign-off for low-blast tests, and finalize list of top 5 models. Week 3 to 6, implement decision-level reconciliation, basic observability dashboards, and instrument rollback logic. Week 7 to 10, run scaffolded chaos experiments in a production-like but restricted environment. Week 11-12, run one controlled production test with full communications, measure SLO adherence, and present a board-ready report. Budget ballpark, small to medium enterprise, $150,000 to $350,000, depending on vendor spend and engineering time. Success criteria, measurable reduction in weekly expected error cost for scoped models, and demonstratable MTTx improvement below your SLO. 2 cautions. First, keep legal and product in the loop for any production test. Second, start with synthetic or shadow trials before toggling anything user-facing. Those mitigations reduce the perceived risk of chaos testing and build trust across teams. Future outlook: resilience scales when observability becomes a product. Automate routine tests into CI for models. Include procurement clauses for rollback credits, or SLAs, and bake compliance checks into deployment pipelines. Over the next 12 to 24 months, leaders should expect increased demand for explainable recovery metrics and vendor accountability during supply chain incidents.
As leaders prepare, they should prioritize 3 actions: funding a minimum viable observability stack, defining board-level SLOs, and institutionalizing a rollback authority. These are governance levers that produce measurable reductions in business risk.
2 actionable next steps before you finish your next meeting. 1. Authorize a funded 90-day pilot with a named owner and a budget line. And 2. Adopt one board KPI, either expected annual revenue protected or median MTTx, and include it in the risk dashboard. Those 2 actions make resilience fundable and auditable.
Final reflection. Testing is not reckless when it's controlled. Low blast experiments, clear rollback criteria, and board-ready SLOs convert unknown failures into quantifiable risk reduction. That's the difference between models and value.
If you found this episode valuable, subscribe and share it with your network. And let's connect on LinkedIn. I'm Mirko Peters. We'll be back with more conversations on how data science and AI create real business impact. Until next time.
Thanks for listening to datascience.show. If you found value in this episode, subscribe, share it with your network, and join us next time as we explore how data science drives smarter decisions and better business outcomes.